How's it going, guys? Today I'm working on this very interesting device. This unit has two connectors. It's broken. I'll show you a close-up of what that looks like in a moment. Today is going to be more of a not follow these steps and this is how I fix the drive. This is going to be an example of troubleshooting and figuring out how to solve problems in the most efficient way possible. What we got is a printed circuit board that had a USB 3 connector broke off of it because of the, I guess, impact. But if we zoom in on this thing, we will see that this actually has two controllers. It's got PS225109 and it has a PS6201. And the reason for that is that because it has this USB-C connector on one side and USB 3 connector on the other side, it needs two separate controllers to operate them with. So the 5109 is the USB 3 controller and the 6201 is the USB-C controller. The job is going to be done using the USB 3 controller, and we'll talk a little bit about how badly this unit is affected. If we look at it from just quick glance, you can see that the damages that's done to this device, it's pretty extensive. Like, there is possibly a way to fix this, but from what I gathered, there's more than one layer on this device. We have outer layer, bottom layer, and there's something in between. USB 3 has more pins. It has 9 pins in this case, but we can still get access to USB 2 protocol using the same controller and using basically the same pinout. So in order to speed the device up, it uses these pairs and these pairs to bump the speed up. But this is USB 2 pair, and that pair, if we run it directly to the controller, it's going to give us USB 2 protocol, and we'll be able to copy data out that way. If we're talking about data recovery, time isn't that critical whether we can work with USB 2 or USB 3, because alternatively, if there was no option to work through USB protocol, we would be working through NAND protocol. And trust me, guys, reading this device using USB, using the NAND protocol is going to be much longer process, and the recovery is not going to be as clean as it would be if we fix this device. So we're going to ignore the PS6201 controller altogether, but we will concentrate on this one. Now, in order to make it work, we need a few things. We could probably surf the net and find what we're looking for in a form of availability for tracing, but we kind of want to make sure that what we're going to be wiring is in fact correct. And for something like that, we're going to need to cross-reference some things. So let's have a look at what's important on our device. We're going to need to power on the controller, so the power will have to get there somehow. Let's have a look at the circuit as it broke off. So the power pin, we've established that it's number 1 here, and it goes up here through the diode, coming out here, and okay, so it goes through the diode, comes out here. This is the capacitor. The rest of the circuit is wide open for it. So we don't even technically need to know how to power on our controller in any special way other than native way. So we're gonna wire a USB 2 connector, which only has 4 pins on it. This is a fairly old one. It's got some lint stuck to it. But even though it's an old unit, for what we're gonna do today, it's perfect unit, because we don't need to use a perfect connector, because it's not gonna be mounted in any pretty way anyways. So this would be a 5-volt pin that runs directly off of the USB port on your computer, and it's gonna power up the device through this pin. This pin will be linked with this end of the capacitor. We have this pin, which is the ground, and the ground can go anywhere on the ground. We can even put it on the other side of this capacitor. okay, because we're going to have power here, we're going to have ground here. That's what the capacitors are like. So what we need to determine, and this is the tricky part, is where are the data positive and negative signals. We need that pair figured out. And if we look, just logically look at the connector side, we have several options. We got a pair that's coming out here, we got a pair that's coming out here, we got a pair that's coming out here. Most likely they're going to be on this end, just orientation wise, for vendor to place 6 traces that need to connect off the connector to the controller. It would be very illogical to run them to these sides, because the traces are going to be so long, right? So the smaller the trace, the quicker the signal will get there. So they will try to put it in the most convenient side to make those traces shorter. So we would think that these pairs are for USB 3 protocol, two of which one of the pairs is for USB 2.0. How do we know which one it is? I mean, there is an option of let me try and see if this works, obviously, but there are 6 wires and we could mix up the positive and the negative, so that's a lot of options to try out from. Even though I'm pretty sure it's not going to do any harm to the device, but sitting here and swapping wires one by one until we get the combination right is not something I want to do. How can we do this? Is we can find a picture online of the same unit that has traces off the connector linking with the controller, and we can maybe zoom in on that picture and browse and literally follow the line to where it connects to. Here's the funny thing is that Phison, even though it has different controllers named very similarly, for example, this USB 3.0 controller, and you can see that this is a USB 3.0, has a controller known as PS 225107-6. If we look at this picture, we can see what we would need to see for our device. We have a 9-pin connector. We can see that this connector is the same type as what we have on other board, because we're using pin 1 and 9 instead of pin 2 and 8 for power and the ground, and that's fairly easily shown here. If ground is connected here, then it's definitely this type of a connector. And 4 and 6 are linked, and they're going straight to this pair. Okay, so we're gonna assume that this corner is where our wires need to go. What I wanted to locate was a Phison controller that has exact same part number, and that's what I got here. It's a device that I worked on in the past, and this is the unit that has this controller available to us. The connector is still attached to it, and the connector that is linked here is also of the same type. It has ground on top and the power on the bottom. Now that we know that the power on our broken unit only needs to come up to the capacitor, we don't need to worry about where the power goes directly on the controller. But what we want to find out is where does the pin 6 and 4 land on this side here. As you can see, we got a pair here, we got a pair here, and we got a pair over here. So if we grab a tester, again, we set it to a beep mode, so if they connect, they will make a noise. You see, we're on the same plane, we're making this beep. No, we're gonna do it this way. So I'm on the pin number 4, I believe. There it is. So the pin number 4 is furthest one. Pin number 6 is the closer one from it. So this goes here, this goes there. Just double check. This pin goes to the top, this pin goes to the bottom. Fair enough. So now we will prepare our device. We're gonna need to scrape up a little bit of actually, we're not gonna need to scrape anything. This is pretty exposed on its own. For the convenience in orientation, the ground is gonna go to this C7 terminal of the capacitor. This is going to be our ground, this is going to be our power, and this pair right there is going to be our data positive and negative. Now the only thing we need to find out is USB pin out. So if you look at the USB pin out, this is what most of the time is the easiest way to find out. It's going to be like just to look at some pictures. We have power, negative, positive, and the ground, right? So now we need to locate a 9-pin connector and see where the positive and the negative are there. Same way, so the power, negative, positive, ground. Same way. I'm gonna add flux to components we're gonna bond with. For power and ground, I'll use a thicker gauge wire. So let's go with this one here. I'm going to turn on fume extraction and just cut them up. One, that's two. For data signals, I'm going to use a smaller wire. We're gonna add flux to the connectors side of things. Now this may not be the best looking thing out there, but I'm pretty sure this is gonna do just fine. So I'll plug this into the DeepSpark USB stabilizer. Let's turn this off for now. This is the tool. For that, let's just prepare everything. I'm gonna plug this into this metering device that's gonna show us what our consumption levels are like. And this end goes here. Alright, so now we're just gonna not breathe for a second. Let's go on to control panel of this tool. Here it is. Settings, we have USB 2 speed setup. Perfect. I'm just gonna select a flash device. And when we power on the unit, we should see some numbers come up here. We see that it's consuming 0.06, so 60 milliamps. That's a good level. Let's have a look at what we got on the log. And on the log, we have PNY dual link Type-C, 57.7 gigs mounted. That sounds like what we're after, because dual link Type-C, if we type in dual link Type-C PNY, we're gonna see what this device looks like, and that is exactly what this device looks like. Here's the unit, and here's what we got in the mail. You guys can see the resemblance, only this is 128 gig and our device is 64. So now that I got it mounted here, we can see the project is available. We got to make sure that we got communication with the device, and I'm just gonna use my favorite RStudio for this alongside with the stabilizer. I'm gonna have them side by side. And as I always show you guys, sector map, I navigate to it, because when we're going to be working with the device through the software, whether we're cloning it or whether we're making direct access to it, I want to show you that we're actually working with the device that we just fixed. So there's our PNY dual. If we go into hex view, we can see that we are actually seeing the proper data in here: invalid partition table, error loading operating system, missing operating system. We have a 55 AA signature, and when we scroll through, we see our device changing to different locations and stuff like that. So let's see what type of data we have. So I'm gonna go ahead and open up portable PC3000. I'm not going to select any devices because we're not going to be working with them. Let's hit OK here. We're going to create a new task in data extractor, a USB to select it as a source, make a copy, and virtual disk. That's going to image the device for us. Yeah, it's already offline, but I'm going to offline it through the tool anyways. If we go into the Explorer, then right away we can see that it has a partition in there, FAT32 partition. We're gonna go ahead and map out all of the used space. There we go. So the device only had 4 gigs of data on there. I'm gonna select scan, and now the copying process is in motion. We're imaging at full USB 2.0 speed, around 35 megabytes per second. And if we look in our map for the USB control panel, we see data trickling out from this device. This is it, guys.